Hi everyone, and welcome back to my desk. It's been a while since I've done any videos, and that is with a good reason, because I was helping my wife bootstrap her own business where she now makes personalized gifts and products. And with her work, one of the things that came up as an issue is that she needs to measure different parts so she can manufacture that on a laser or on a 3D printer. And for that measurements, we use these digital calipers to do precise measurements, and they work great. They are both manufactured by Parkside, which is a brand in Lidl, and you can then measure the distance. For example, if you need the distance, the measurement of this cap, then you could measure it with a good precision and find the reading really quickly. But one of the issues that we faced with them is that they turn on automatically whenever you move them. So for example, if I just pull on the handle here, you'll see that it now turns on automatically, and you need to turn it off and lock it. So when you are handling this, it will not destroy the battery inside, and it's good to go on your next use. The same thing happens on this other one. So this is basically the same caliper but with slightly different manufacturing date. This one is a bit older and this one is the newer, but they both are exactly the same. And you could see, even just by handling this, any slight movement will turn on the battery, and basically when you need it, it will be off and the battery will be flat. So to help solve that, I've purchased two switches. These are not momentary but latching switches that you can press to turn on. So this one latches and then it releases, and the plan is that I open this up, modify the circuit inside, find a place that I can fit the switch. I was thinking something like here, so it won't interact with the regular operation, but we can still interact it and completely disconnect the battery when this is not in use. We keep the calipers in their original boxes, and you could see that on both of these cases there is some extra room on the bottom where even if I place the switch inside, it will still have enough space to be in the box and live together with it. So let's start by opening this up and figure it out where we need to make changes in the circuit so we can add the switch. Now, if you're watching this video, chances are that you are a maker of some sort and that you make project, or you have some manufacturing capabilities since you have interest in calipers. And if you want to take your project and manufacturing capabilities up a notch, then I would suggest you to check out this video sponsor, which is PCBWay. I use the services of PCBWay every time I need a custom part or a PCB for my project. PCBWay provides services for 3D printing, injection molding, CNC machining, sheet metal fabrication, and a lot of other manufacturing capabilities. Upload your Gerber files or 3D models and they'll provide you with an instant and upfront quote for the order, making them a perfect choice for all of your manufacturing needs. Thank you PCBWay for sponsoring this video. Now back to the build. I'll first start by removing the battery, and this is one of the differences that are on both. This one has the screw on the back, while the green one has the screw on the front. Okay, and this is the battery. Okay, now how do we get into this? I'm thinking that there'll probably be either some clips or some screws here on the back. I cannot feel any screws here on the back, so I'm thinking just maybe clips on the sides. Let's try that. Actually, there are some screws here on the top inside. Okay, they don't seem to make any difference. Let's try and see if there's anything Yeah, so we do have screws on the back, so I'll need to remove the sticker. Okay, so this is that, and there seems to be, yeah, this is just a sliding piece, so this is purely mechanical. We're gonna leave that on the side, and this is our area of interest. There are 1, 2, 3, 4, 5 little screws holding this PCB in, so let's take them out. And in theory this should now just come apart. Okay, let's make sure we don't lose any of the buttons. Okay, we'll see where that, that's on the top. Okay, now what do we have here? Okay, so based on what I'm seeing, our best bet would be to cut the trace that's coming from the positive of the battery. You could see that it goes here in the back and it powers the rest of the circuit, because the negative one seems to be going down this rail, and there are some vias in between that we cannot disconnect. So I'm gonna try to first remove this clip for the battery, terminate the track that goes here on the first pads, and add 2 tiny wires that we can route here around, and they can come from within here, because in the box this is where the battery is, so we can probably route the wires in below the battery, depending on how low this goes, and from there they can come from a small hole here on the bottom, and we can have the switch now right next to them. Let's try that. Okay, so what I did was to make a break in the PCB track that goes from the battery positive to power on the circuit, and I exposed a bit of the copper underneath, and I ground out the insulation, so I added a bit of solder. We'll now add a wire coming from here and another one from here, and we'll route it out this way so we can take it outside of the caliper and add the switch. As for the wire, I'll be using the thinnest wire that I can find, and this is 0.15 that came from a coil from a power supply, an LED power supply, and this is insulated wire, so I'll need to burn off the insulation at the end so I can solder it, and then it will be isolated all the way out till the switch on the outside. Now, drilling a tiny hole won't be an easy job, because we'll need to mount this precisely and drive it with something like 1mm, which I don't have. I actually do have, but I don't think that it will fit in the chuck of my drill, so I'm gonna try something else, and I've prepared this for that. I wrapped just a piece of copper wire on the soldering iron on the side, because I don't want to destroy the tip, and I'll try to drill into the case seems to be working. Let me make sure that I have the right position. Okay, I don't know if that's enough. Let's try and make it just a tiny bit. And make sure that I don't burn myself. Okay, let's see if that's enough. And yes, that seems fine. Now let's try and add the wires. Okay, well, we lost one of the wires, and that's not good. Let's repair it. So that feels right. Okay, I'm gonna add the small screws and I'm gonna try this out before I go any further. Let's try and strip the ends. See if the theory works. Okay, so when I touch these, they should start working. If I connect it, it turns on. If I disconnect it, then it goes off. It's the values all over the place because we are now not having the magnetic reference that it has there. So it just jumps all over the place, but we should be able to fix that easily once it's on the actual caliper. Okay, let's try it one more time. Okay, that seems to be working. Awesome. Let's put it up together all the way and add the switch. The switch that I'm gonna be using is a bit specific because it has a normally open and a normally closed connector, and it has two sets of connector with what it is. So I'll only need these two pins that I've added solder to, and these are the normally open contacts, so when I press it they'll get connected and then disconnected. So I'm gonna trim the wires here, solder them to the connector. It's better if you can see. So I'll trim the wires, solder them to the connector, and then I'll mount the connector on the case. If I did that right, pressing it should turn it on, and it does. Nice. And to glue it on, I'm gonna add just a drop of super glue, and that will be placed just here. I added just a tiny bit to the wires as well, so now this one is complete. I'm gonna leave out the back sticker, or maybe I'll place it on. Yeah, that wasn't good there, but it's okay. And the final test, will it fit in the box? Yeah, no issues there. And as well as being closed. Now to the second one. Here on the second caliper we have a very similar but slightly different situation where we still have the battery holder there, and there is just a tiny trace that goes from the clip to this capacitor here, and that capacitor is connected to ground as well, so we'll need to cut this off, and I'll solder it to the side of the capacitor and to the battery holder and route the wires exactly the same in between those pins there, so in between the button, and come out from the side here. Okay, so let's give it a go. Currently the wire is connected, so in theory when I connect the battery it should start working, and it does. I can turn it on, and if I cut the wire it should turn off. Cool, that's working. Now let's put everything back together. And here are now both of the calipers done and modified, and we can decide to turn them on when we want and turn them off so they don't waste the battery when they're in storage. And if we move it, we'll see that they don't turn on automatically now, but only when we choose to turn them on they turn on and continue. If you notice here, you'll see that I've used a different style of switch for the green one because I had this one failing on me, so it turns on but it doesn't turn on unless I pull on the lever, so something must have broke inside, or I don't know what the issue was, but this style of switches do exactly the same job, and we can easily toggle between on and off. Everything else still works, so we can zero it at any point. We can lock it at any distance, and we can still turn it on and off using the built-in buttons, but if we turn it off, then when we move it will not turn on. And with that, I hope that you like this video. Make sure to like it down below. Make sure to subscribe so you don't miss any of the future projects. If you have any questions or ideas for future videos, leave them down in the comments, and I will see y'all in the next one. Cheers!